Now.
Okay. Now we are unmuted, and there's 14 people online. Welcome. We are gathered here in our Albuquerque Office of Reclamation, and just so you know, this is being recorded. Those of you who are online, you do not have the capacity to turn on your microphones in Teams Live, but we have turned on
the sound effects thumping in the room.
We have turned on the question. That means it's 2 o'clock. We have turned on the question and answer, so you can type your questions, and then the 2 facilitators in the room will ask your questions out loud for the speakers. So I will turn it over to Jennifer Fagler, our area manager for Reclamation.
Hello, everyone in virtual land. This is our hybrid annual operating plan meeting. It's great to have folks in the room. I'm guessing if we had any last year, it wasn't very many. I'm pretty excited about today, trying to figure out where we're at. Usually we kind of set the tone for the water year, and this year, since I've had crews up fighting floods on the Jimenez River, I thought it might be a good year. So I looked at the SNOTEL. Thank you, Rick, for the technical support on hitting now. So I'm actually getting today's SNOTEL. But the dark blue is everything above 150%. That was as of April 18th. And so I'm going to hang this up on my wall and hope we do even better next year. Certainly looking back, it hasn't looked this way. So all that over 100% of snow still up in the mountains. So exciting times this year. Today is the day that Reclamation demonstrates its commitment to collaboration and transparency, because not only do we, along with the Corps' modeling, kind of lay out what we think is going to happen this year, we admit where we were on and where we were off last year. So we showed the results of last year's predictions and how they're stacking up. So proud of this federal agency. Couldn't be more proud of the Albuquerque area office. We are working hard. We have a great group of folks here that just put in their all every day, whether it's water operations in this team. Our support to tribal nations has just gone up asymptotically. We're trying to bring in as much of the bipartisan infrastructure and Inflation Reduction Act money as we can, and it's just a flurry of activity around here. It's pretty exciting. It's with both a joyous and heavy heart that we introduce, I'll let Carolyn introduce Lucas, but we did, Ed Campbell retired, and we've also lost Raymond Abeda, who passed away a couple weeks ago now. So it is a real changing of the guard here. Like I said, with a heavy heart, but we have these up-and-comers. Lucas is not an up-and-comer. He's been doing this modeling for a long time. And if you've seen our information, it probably came through him for the last several years. So just proud of this team and all that we do here. And it's a busy time of year. It's an exciting time of year because you're about to hear a lot of information at the Compact Commission meeting as well as here. So you can imagine how long this team has been working to prepare information. So it's a busy 2 months for them. So thanks to the Water Ops team, and they attend chili cook-offs and all those other things that happen in the office. I'm not sure who won yet, but we'll hear probably during this meeting. So with that, welcome all. Excited to share the information. Hopefully it's good news. I didn't see the pre-presentations last week because I pulled it up for good news. So hand it off to you, Carolyn.
All right. Thanks, Jennifer. We wanted to start off with a little bit of more like a climate outlook. So we're going to have Andrew Mangum from the Weather Service start us off. And then actually, we're not going to talk about the Pecos River here. We're going to talk about the Rio Grande River. So Andrew, let's go.
All right. Get me fired up there. Thank you. All right, good afternoon, everybody. Jennifer, yes, this is going to be good news for me, by and large. So we're going to talk a little bit today about water year 2022. Mostly we're going to focus on the 2023 monsoon and water supply outlook from our office. We'll go through a little precipitation review, talk about the snowpack, soil conditions, drought conditions, climate outlook, and then finally we'll walk down the river and some water supply outlook as well. Here we go. Skip one. Here we go. All right. So These are two graphs of kind of total precipitation in 2023. On the left is actual total precipitation, and it just doesn't look very encouraging. I mean, this is the Southwest, it's not the Midwest. And so a lot of the area is in 5 to 10, especially in the eastern part of the state. But you do see some really encouraging areas where it gets up into that 25 to 30 to 35, even in the Southwest part of the state, really high numbers up in the 45 to 50 range, which is fantastic. I think sometimes a more useful way of looking at this is to look at the percent of normal precipitation, looking at this is comparing it to 30 years of precipitation in the background. And I think this is a bit more telling that we are mostly above average in the eastern 2/3 of the state and way above average in certain parts of it as well. So that's encouraging. Western 2/3, not eastern, left and right, get those mixed up. Thank you, sir. But keeping the wrong button. All right, another way of looking at this is off our AHAP site. This is all radar data, no ground truth in it, but it tells a similar story as well. That the western 2/3 of the state are remarkably wet, as if we look at precipitation as a percent of normal. Again, eastern thirds, edging up on the eastern half of the state, kind of missed out on all this, but it still hit most of the Rio Grande, which is good news. This is last year. So I kind of like to go back and forth between these two so you guys can see the difference. Last year, we were well below normal over most of the state. And only in a few areas did we do okay. This is this year. Last year, this year. Good news for precipitation all around, much wetter pattern all around. Let's take a look now. This is kind of the Rio Grande area running through here, right? And we're seeing some pretty impressive snow numbers feeding into the Rio Grande. We have some areas up here that are in that like above 600 inches of depth kind of zones, colors. Plenty that are in the 120 to 180, getting up to 240, 360. It's a little muddled, but we had some really impressive snow numbers. I mean, the main point of this is just that we had a really wet monsoon last year, and now we've had a really wet winter this year, and that's really set us up really well. Keyboard to work. So let's compare the Rio Grande basins here. We've got the headwaters, the upper Rio Grande, and the middle Rio Grande here in terms of their snowpack. This is last year, where at the same time last year, about April 16th, we were below normal in all of those basins and almost half of normal down in the part here. This is 59% or 69% down here, 76% of normal, 87% of normal, looking back over 30 years. Here's where we stand right now. 123%, 150%, 212% of normal. This is all based off SNOTEL data. These are gauges that are way up on a mountaintop and get averaged together for the basin data. And so it hides some of the really exciting figures in here, which was that there are a number of points in here that show a record snowpack. I mean, absolutely blowing the record out of the water. All of these basins hit at least the 70th percentile for the last 30 years. Many of them, including the middle one there, hit the 95th percentile for the last few years. So really impressive snowpack, really good situation leading into the melt in terms of water supply. So let's take a look at, instead of just kind of spatially, let's take a look at the time evolution. This black line here is this year's snowpack in the Rio Grande headwaters, right? This blue line here is last year. So we really did quite a bit better. We maxed out at about 12 inches of snow water equivalent as opposed to like 18 inches of snow water equivalent for the peak. And we kept going past our usual peak accumulation date for quite a while and hung on to it. That's starting to roll over now. We're starting to get the melt come out, which is, you know, that's how it happens and that's all good. So that's the headwaters. If we go to the upper Rio Grande, this one got way up into the 70th percentile really comfortably, went way past the peak accumulation date. This is last year's data, way above it. So again, we hit up around 15 inches, so we pretty close to 15, 14, as opposed to 8, right? So much better water supply situation there. This is the one that got up to the 95th percentile. This is the Rio Grande Elephant Butte, and this was just a remarkable amount of snow. They don't get as much, right? So it's still only like 13 inches of SWE, but the median is 7, right? So we almost had double the snowpack there, and we're sitting right now, we're well above it. We've had a slow melt from that, so that's why we're reading 212% of this at this point. And again, we went way past the peak accumulation date, so lots of good snow out there to get into our rivers. If we take a look at the drought conditions, and this is where I'm going to start talking about what the soils look like. Take a look at the drought conditions from last year. Overwhelmingly, we were in severe to exceptional drought throughout the entire Rio Grande Basin. These soils were really dry, We were having lots of problems with fire, all that. This year, after the incredible monsoon that we had, and that really cannot be stressed enough, the monsoon that we had last year was one of the strongest that we've seen in 130 years in some of our climate divisions. After that and the wet winter, actually a really good proportion of the Rio Grande is showing no drought conditions at all, or maybe just abnormally dry. Well over half of it is no drought to abnormally dry, which is good news. As you get further east and south, you're getting into the very dry parts where they really have not benefited from any of this precipitation yet, and they're still under some pretty severe conditions. So this gets us to soil conditions. Soil conditions are important when we start talking about runoff efficiency. And this is something I like to hit on for people because over the last 20 years, we've had some years with good snowpack that have just not delivered. Not the way that they should have, not the way that they were 30, 40 years ago when you had the same snowpack. And that's because we've just been parched for 20 years. We've had baking heat, drawing all the moisture out of the ground. And so a lot of that runoff just gets infiltrated and soaked up, never makes it to the rivers, never makes it to the reservoirs. This on the left shows the change in percent soil moisture over the last year, from last April to now. And this includes some really bakingly dry months. April and May were terrible last year. We only had 0.05 of an inch of rain in the entire state in April last year. So this includes all the monsoon and the wet winter really driving up this big change in soil moisture. But this is the one I really like to look at because this is a percentile. This shows you how wet the state soils are kind of relative to themselves over the last 30 years. And the fact of the matter is that 2/3 of the state are pretty much pegged out. They're at least wet up to saturated, and especially up here in the mountains where we have all that snow. And over here where there's plenty of snow as well. But more importantly for the Rio Grande, kind of running through here, we have soils that are right at the top of their percentiles for this. So the soils are saturated. That means that we're going to get a much more efficient runoff. We're going to see a lot more water coming out of this snowpack. And that's really good news. Now let's shift gears a little bit and talk about climate, because when you're talking about water supply or flooding, you have your conditions that are set up. You have how much snow you've got, you have how wet the streams are, you've got how wet the soils are going into the melt. But the wild card is always the climate. So that's what we're going to shift gears and talk about now. Now, we've been stuck in La Nina conditions, which usually means a dry winter for the last 3 years. Didn't work out this year. We had a pretty wet winter, which was nice. It was kind of a bonus winter. Starting early this year, we started seeing increasing signal for a pretty sharp transition to what we call neutral conditions, ENSO-neutral conditions, with the hint that we might actually get to El Nino conditions, all right? By now, in April, we are out of that. We're on an El Nino watch, and we're really confident that we're going to move into a really strong or a pretty strong El Nino condition moving through the rest of the year. Why is that good news for us? Well, El Nino winters typically are wetter and snowier, and so we're looking at this is a kind of good outlook for at the end of the year in the winter. Trying to relate this to trying to relate what this does to the jet stream and does to the path of storms to the monsoon is a little harder. Right. Some years El Nino leads to a pretty strong monsoon. Some years it leads to a non-monsoon, and you end up with situations that makes it a little bit hard to predict. So it's a little hard to say what this is going to do for us this summer. We'll get into a little bit more of what we're thinking as we move forward here. Okay. So now we're going to jump into the outlooks. I'm skipping to like the month outlook. This is the month of April. We'll kind of finish out with this. One thing I want to say about all this, and I am a little uncomfortable saying this because it's my organization that's putting these outlooks up, but they've been having a lot of problems with them, like the monthly and the 3-month and the seasonal outlooks this year. If you go back to November, they kept saying, we're going to be warm and dry. We're going to be warm and dry. No, in December, we'll be warm and dry. How about January? They kept saying it, and it just wasn't happening. And talking to them, it seems like one of the problems is that the long-range models are really struggling with how sharp the transition is from La Nina conditions to neutral to El Nino. It's all happening fast, and the models aren't used to moving that fast. And so they keep biting down on drier, warmer outlooks. And that's what I'm going to show, but I do think it's worth taking with a grain of salt this year. I really do. We have been consistently outperforming the model in terms of being cooler and wetter. But let's walk through this because this is the official National Weather Service outlook. All right, so for the rest of April, we're looking at sort of equal chances for temperature, sort of normal temperatures through April, not that cold, not that hot, and equal chances for rain. This is actually pretty accurate, and that's partially because it already incorporates a couple weeks of April in it. So it's looking pretty good. And we've been doing all right. So we're going to have a totally different April this year than we've had last year, where again, we only got 0.05 of an inch for the entire state. As we move forward to the April, May, June timeframe, this is our fire weather season. This is the driest time of the year. And so this is probably not too inaccurate, right? That we're calling for above normal temperatures, below normal precipitation. It is that time of the year here in New Mexico. This is a problem for water supply, quite frankly, because as the winds crank up and the humidities drop down into the single digits, we're just going to lose some of that high elevation snow to evaporation and sublimation. And that's going to be a problem for us, but hopefully it won't be too bad. As we move forward, May, June, July, we're starting to get through that dry season. You see it's still warm, but now we're picking up that signal in July where we start to get our monsoon rains coming in. So we're getting equal chances of rain across the northern part of the state up into Colorado. And then finally, as we get into the heart of monsoon season, again, they're still calling it for warm, but they're saying equal chances. So what can I tell you about the monsoon? It's tough to forecast the monsoon, but we're not looking at anything that suggests we're going to have no rains. We're also not looking at anything that suggests we're going to have the same monsoon that we had last year that really did have some beneficial effects on the reservoir. So I don't think it's wise to bank on heavy rains like pushing the reservoirs up at the end. But we also don't think you're going to get hurt by a low monsoon. Sir?
So last April, what were you saying about our monsoons last summer?
Last summer, we were saying that we were going to have a decent monsoon.
In April last year.
In April of last year, we were saying we were going to have a pretty decent monsoon. We were not ready for how good the monsoon was.
Congratulations.
They swept the wind. We were happy about it, except we're extremely busy for the entire summer issuing warnings. But it's a good problem to have, too much rain. All right, so in terms of the drought outlook, what we're calling for is persistence of really bad drought conditions in the eastern third of the state, but also over the course of the next few months, we're looking at an intrusion of drought conditions, a degradation of those conditions through the central and southern part of the state for sure. And that's pretty typical in New Mexico for this time of year. This is when drought tends to develop pretty rapidly through that part of the state. Finally, before we get into the full-on water supply forecast, let's touch briefly on stream flow conditions. So we have a scale here that goes from low, which just means like the lowest you ever see at this time of year, to high, which means the highest that you ever see for this time of the year. And that's what this is really important to get at. This is talking about like a snapshot compared to this day for the past 30 years. All right. What we're seeing here is a lot of these light blues and dark blues along the rivers and the streams. And when we're seeing colors that aren't in those really high levels, we're seeing colors that are still kind of in the normal levels. And we have some that are tucked up in there that are a little hard to see on the screen that are the highest they've ever been for this time of year, according to the period of record. So the streams are pretty full. Those channels are already kicking. And that means that more of this runoff is going to get delivered. So again, this is just pointing to wetter conditions, a more efficient runoff, higher base flow going on in all the streams. So now let's get into the forecast. So I want to talk about how we do water supply forecasting. I'm sure most of you are familiar with this, but it's worth walking through what this graph means. So there are two different models presented on this graph. There's the National Weather Service model, and there's the NRCS model. The way the National Weather Service model works is a little weird, but let me try to explain it. We are modeling the hydrologic response based on soil conditions and precipitation and temperature. And we're generating the flow that we would get out of a particular basin from that. Then we are pretending that there are no dams. There are no acequias, right? We're just as many saying this is natural flow going through these mythical prehistoric rivers that come through here. And this is all unregulated flow. That's what we do. And that's what's presented in this large shaded area. You've got the 90% exceedance interval. We're definitely going to get this much. You've got the 10% exceedance interval. We would love to get this much. Then you've got what we really think is going to happen is the 50% exceedance interval going through here, okay? These vertical bars represent the NRCS forecasts. And what they do is that they do statistical analysis of, am I saying this wrong? They do statistical analysis of stream gauges, right? And those gauges, because they're downstream, a lot of the releases and the controls and the diversions and stuff like that, they kind of take all that into account. So they're a little bit more of a realistic snapshot of how the gauges tend to behave given the precipitation that's on the ground. But there's no hydrologic modeling necessarily going on. This is just statistical analysis. So they're two very, very different models, but they both have a lot of utility. Now, we at the National Weather Service, with the support of some funding, thank you very much, have been working on recalibrating the Rio Grande basins. And there's showing some really promising results. Those calibrations are getting rolled out right now, especially in the northern basins. And we're starting to see better agreements between our numbers and the NRCS numbers to give you a little bit more confidence about what to use here, okay? So we're going to walk through all of this. Here's the average, the median, max volume, min volume, and we'll go through this one by one. But the numbers to really don't pay attention to this because it's really hard to get the current snapshot to show up in these numbers. Pay attention to this stuff up here where it says it's 390,000 acre feet, 122% of average, 126% of median, okay? We have seen our water supply forecast steadily climb through the whole winter. This is going to be a theme that just gets repeated over and over again. And so now we are in the zone where we are forecasting. This is April through September that we start forecasting from the Rio Grande and Wagon Wheel Gap. And we are showing a pretty confident forecast. We're a little bit lower than the NRCS, but not that much really. NRCS is holding firm there at about 350 or 375. We're kind of at 350. Not a huge difference. No matter what, higher than the average or the median. So that's good news. As we walk down, I'm just going to walk through these. It's kind of the same story. We have the Rio Grande River near Del Norte, very good agreement between our models through here. 132% of average, 130% of median for the 50% exceedance. All right. We go through Alamosa. This is one of those areas where we really don't agree very well in our model. We're still sussing that out. We typically are much, much lower. I think, honestly, it's probably safe to go with the NRCS numbers on this one rather than ours and bank on that being kind of a higher forecast. I've been there showing 150% of average there. Conejos River near Bogote, you know, a little bit of disagreement here. They're a little higher on this last one than we were, no matter what. Again, 158% of average, 167% of median. We're talking about 275,000 acre feet from the NRCS versus 225,000 acre feet from the National Weather Service. As we keep going, this is one of the ones that hasn't performed as well just because of the vagaries of snowpack development. But the Culebra Creek is a little bit below average. Still doing okay. It's still kind of hovering around normal. That's a lot better than it could be and a lot better than it has been in past years. Same thing here at the Red River below the Fish Hatchery, a little bit below average, but it could be worse and it's still coming up or has been coming up. The Rio Hondo near Valdez, right around normal for both of our forecasts, which is about 15 to 28,000 acre feet. We get up here at the Rio Pueblo de Taos, we're a little bit more optimistic than the NRCS. In this particular instance, we're saying that it's going to be like 50,000 acre feet, and they're saying a bit more like 32. Moving forward in Budo Creek at Dixon, it's a small tributary, but you know, it's every little drop counts, right? We're in really good agreement that this is about 176% of average. Santa Cruz River at Condil, above average. This is just over and over again the story. Above average. Rio Chama below El Vado Dam, remarkably above average, right? We're doing, yeah. Want some firm numbers on that? Like we're both looking at about, we're both expecting somewhere in the neighborhood of 325,000 acre feet.
Which is 168%.
Yep. Yeah, 330,000 acre feet. There you go. So that one's pretty good. That's a major player in terms of water supply. And that's where we kind of end. I could go to some other points, but we model some points that the NRCS does. They model some points that we don't. And it's really hard to get the models to agree because they're so fundamentally different. The point of all of this is that, to summarize, we've had a really good wet year with a really good snowpack, and we've got really wet soil conditions. So we're expecting to get most of that snowpack, and that's driving all of these above average forecasts for water supply. So in a given year where someone would want to be more cautious and use the 70% exceedance to kind of hedge their bets against a drier year, this might be a year where you could get away with using the 50% exceedance and feel pretty comfortable about it. I'm not saying you have to do that. It's fine to be cautious, but this is a year where we're feeling remarkably optimistic about the water supply. And with that, I'm happy to take any questions.
I think let's go a little slower than we did this morning between the two, because it does take them a minute to hear us ask for questions and for them to type it in. So does anyone in the room have questions while we wait for any typed in questions?
Sir.
Is there anything qualitative collected on snowpack, the density of the snowpack?
Oh, like how ripe it is right now? That's a little bit tricky. I haven't seen any snow core reports come out yet. I'm not sure. I think Jazz may be doing some of those. So there may be more information that next week at the Rio Grande runoff meeting, once the NRCS gets out there and does that. I can point you to model data that does get into what the actual water equivalent would be. I'll tell you right now, if you kind of averaged out a lot of these basins, we're looking at somewhere between 8 to 10 inches of water equivalent still left up in the mountains, even after the last couple weeks of being really warm.
And I was specifically thinking about some of the blowing dust and sublimation problems we've had in the past 20 years.
Yeah, that's a real issue, especially now we're seeing the relative humidities drop down to single digits this week with winds cranking up. Not too bad, not as bad as we've seen sometimes. We're not expecting any 50-mile-an-hour gusts or 2% humidity, but it's still going to bring it down. And the blowing dust is a real issue because it gets on top of that snow, fundamentally changes the albedo and encourages more sublimation and melt.
So in summary, we're in okay shape on that.
We really are we're in better shape than we've been for a good long time, even with the conditions that happen every spring. The snowpack has had a chance to ripen, right, and compress. You know, it's not like we have 7 inches of SWE and then 70 inches of snow. It's more like we have 7 inches of SWE and then 15 to 20 inches of snow, right? So it's a pretty ripe, wet snowpack, and that makes it a little bit more resilient when it comes to this issue of sublimation.
The data you presented pick up the San Juan Trauma Project watersheds.
Yeah.
How those bring water to Heron.
Yeah, how those bring, so yeah, I mean, I can show you some, well, I can't right now, but I can give you data on some forecast points that we have, some gauges that we have talking about that, some of that flow. But if you want to talk about how that water is going to be delivered, it's the same kind of story, right? All of the basins that feed the San Juan are, if anything, doing a little bit better than the basins that are feeding the Rio Grande. There's a tremendous amount of snow in southwestern Colorado. And so we are looking at already some very elevated flows in the Animas and in the Chromo and things like that that are coming down Little Navajo Creek. So same kind of story, really. There's going to be more water coming out of that than usual.
I'm going to hit a little bit about that as well.
Yeah.
Okay, good.
Yeah,
Good.
because
Let the experts in.
what makes it into Heron is going to be affected by our operations.
Okay.
Yeah.
Yes, started talking about some stuff I
Let's assume
totally
that the
understand.
water's not there, right? So that water is just
Yeah.
moving right on down.
Right, yeah. Which in this particular year kind of is the case, isn't it? With a lot of, they're just mostly past. So,
Andrew, we did get a question through the chat, and they asked, what are the chances of much of the snowpack with high winds? Maybe thinking back to last year.
yes, maybe thinking back to last year. Well, it's hard for me to give you a hard number, like it's a 50% chance we're going to lose everything. That's not what I'm saying at all. I actually think because we had a late snowpack and some warm temperatures before the winds hit that allowed that snowpack to ripen and turn into a dense, heavy, wet mass, that I think we're actually going to be seeing less sublimation than we usually see off of this. We're not seeing any crazy signals for radically high temperatures, radically low humidities, cranking winds. We're not seeing the same kind of signals we were seeing last spring for fire weather season when we were forecasting a genuinely awful fire weather season. But it's going to happen. So it's a bit of a mixed answer. You know, we're still going to get high winds and low humidity. It's that time of year. So we are going to lose some of this. I just think we'll lose less than we usually do.
And I guess from my perspective, I'm looking at, say, Cumbres Trestle, which is a high elevation site, it's snow-tell site in the Rio Chama Basin that still has 40 inches of SWE. And so we may lose some, but okay, that might leave us with 35 inches
Yeah.
on and off.
Yeah, that's the other thing. If we sacrifice some move, there's still a fair amount in the bank up there for us to get. So it's pretty good. Yes.
So when you were talking, not to bring up a sore subject, talking about how the long range models are having trouble keeping up with the pace of change.
Yeah.
Could you describe a little bit the parameters that you're talking about that are switching so quickly?
Yeah, the ocean temperatures are switching way quicker than what we've seen before. We're actually having one of the fastest changes in subsurface or near surface ocean temperatures just below the equator that we've seen in 20 years.
Okay,
Yeah.
thanks.
That is unclear to me. I'm actually not a climatologist. I am a hydrologist. I try to get you some answers on that, but I think there's a lot of scientists who are kind of scratching their heads about why that transition is happening as fast as it is.
Is it both directions, or it's going up faster, or it's going down faster?
It's going up faster. It's warming quite a bit. I wish I could give you a good answer to why that's happening so quickly. I'm sure actually hundreds of scientists out there wish they could give you a good answer to why that's happening so quickly.
Thanks.
Thank you.
All right.
We move on to the operations, to Lucas and Ray. Escape.
I hit escape. It wasn't doing anything.
No, you're stuck to my talk.
Just redo it again. I mean, such a good.
Let's hear Lucas do your talk.
There you go.
You'll do a better job.
All right. As mentioned, my name is Lucas, and I'll be co-presenting this with Ray from the Corps. So I think Andrew basically said, I mean, the main idea of our presentation as well, it's going to be a really good snowpack year. It's most likely going to have really good runoff, and we'll see that throughout this presentation. As Jennifer mentioned, I know Ed Candle used to do this, so if for some reason I do a bad job, you can blame him for retiring. Oh, yeah, you're right, this keyboard is not working well.
Are you running it off for this one?
You can use the mouse.
Yeah, the mouse seems to work at least. So going through this presentation, many of you, especially if you've been here in the past, may have seen some of these slides before, but for those of you who may not be as familiar with these terms or agencies, I kind of just want to run through this very quickly. There's multiple different terms, and also, as you can see here, agencies, and that I'll be probably referring to throughout most of these slides. So I just kind of want to give you a heads up. So I'll be referring to basically Reclamation, which is Bureau of Reclamation, Corps, or USACE is the Army Corps of Engineers. Also talk about IBWC when we get down to like Elephant Butte Caballo, which is the U.S. section of the International Boundary and Water Commission, the NRCS, which Andrew was mentioning earlier, Santa Fe with the City of Santa Fe Water Authority, or the Albuquerque-Bernalillo County Water Utility Authority. There's also MRGCV, which is the Middle Rio Grande Conservancy District, and then we have two districts south of Caballo, EBID, which is Elephant Butte Irrigation District, and EP1, El Paso County Water Improvement District, and that includes the city of El Paso. Also, some other things to basically keep in mind as I'm going through this presentation. There's a lot of policy that actually dictates a lot of what happens in terms of reservoir releases and what operations take place. These can include any of these 5 examples, such as like the treaty, the 1906 Convention, which is between U.S. and Mexico, the Rio Grande Compact, which is between, of course, Colorado, New Mexico, and Texas for appropriating how much water goes to each of the 3 states. One thing that's important is the Article 7 restrictions, which basically restricts storages of Rio Grande water in post-1929 reservoirs, such as El Vado, when usable storage in Elephant Butte and Caballo is less than 400,000 acre feet. Then there's also the actual project authorizations, which in turn, I'm just talking about the actual project of each dam, has its own set of federal laws that apply to its storage and release of water. And then there's also the operating agreement, which is an agreement between EBID, EP1, and Reclamation that was signed just recently in 2008. And then the last thing to keep in mind is there's also multiple different types of water. So you can kind of think of these as like different accounts that we have to keep track of. So first of all, there's native or natural Rio Grande water, which is basically water that comes from within the Rio Grande Basin. Then there is San Juan Chama water, which is water that's imported through the San Juan Basin, basically through the San Juan Chama project, and that gets diverted through a bunch of pipes that go underneath the mountain and go through Azotea Tunnel and come up right above Heron Reservoir. I'll also mention supplemental water, which is water that's leased by Reclamation to augment flows in support of the Rio Grande Silvery Minnow. And then finally, there is P&P water, which basically stands for prior and paramount. And that's talking about the prior and paramount lands of the 6 Middle Rio Grande pueblos, or I should say the water for them. And then last of all, this is the last slide of definitions. I'm sure you're tired of it already. There's CFS that's basically going to be used. That's a flow rate, cubic feet per second. And I'll use it for basically when I'm showing the hydrographs, which hydrograph is a word up here, which is basically the graph of the flow rate over time. Then there's also acre feet, which I skipped. That's basically just mentioning a volume of water. I'll be using it when I show graphs of of the reservoirs and the amount. And it basically is the amount of water needed to cover 1 acre foot to a depth of 1 foot. Next, there's the runoff forecast, which is basically what we were going to be presenting. And this is just predicted stream flow volumes for March through July provided by the NRCS. And then the last thing I'll mention is the SNOTEL, which I know Andrew talked a lot about as well, which is the snow telemetry network, which is basically a bunch of automated data collection sites high up in the mountains, remote high elevation mountain watersheds used to monitor snowpack, precipitation, temperature, and other climate conditions. So just to kind of give you all an idea, if for some reason you aren't familiar with the Rio Grande Basin, kind of just going upstream to downstream in terms of different our facilities and everything else. So on the left, you will notice basically it's a map of mainly the San Juan Reclamation San Juan Chama project. So at the very top, a lot of these sites, at least for the people in the room, I know it's kind of hard to see. At the very top, though, you'll notice that there's the 3 diversion sites, Blanco, Oso, Little Oso, that go through, and that's basically part of the San Juan Chama project that I mentioned earlier that diverts water from the Colorado Basin to the Rio Grande Basin. And then that water that gets diverted flows through Azotea Tunnel and then finally flows into Heron Reservoir. And then Heron Reservoir is actually off stem of the Rio Chama. So, but right above El Vado Reservoir. So El Vado Reservoir is actually along the Rio Chama, and just downstream of Heron Reservoir. So it will basically get the flows of both any outflow from Heron Reservoir as well as the Rio Chama. And then below that we have Abiquiu Dam, which is the last major reservoir along the Rio Chama, and then we have the confluence of the Rio Chama and the main stem of the Rio Grande, and then downstream and then we have a couple major gauges that I'll be talking about later. So you can kind of see a little X, that will be Embudo gauge. That's just along the main stem of the Rio Grande. And then below the confluence of the Rio Grande and Rio Chama, we have Odawi gauge. And then right below Odawi gauge, we have Cochiti Dam. And then going over to the middle graph, this is basically the middle, or not graph, but map. This is basically the middle Rio Grande project. And you can kind of see that it will basically take, it shows a little bit of the Rio Chama, and then it basically looks more at the middle Rio Grande project, which is between Cochiti and Elephant Butte. So from there, you'll see one other gauge or 2 other gauges I'll be talking to about is Central Gauge, which is right at Albuquerque, and then Santa Casia Gauge, and then that all encompasses the MRGCD, and then finally going on to the right map, you'll notice Elephant Butte Reservoir at the very top, and then that will lead into Caballo Reservoir, and then right below Caballo Reservoir starts EBID, and then that goes into one. So one thing I wanted to mention is kind of what drives, I guess you could say this modeling process of starting with these NRCS forecasts and going to going to a daily stream flow forecast that we're going to show in this AOP. So first of all, as mentioned, we have these volumetric forecasts from NRCS that go from either March through July or April through August, depending on which site you're looking at. And basically, the model will take those volumetric forecasts and implement it into. It will basically ratio up and down, selecting a similar year based off of a similar volume. I kind of briefed over the based on but essentially NRCS is based off of snowpack, soil moisture conditions, and climate forecasts. But it's mainly it takes into that account and uses their statistical method to come up with those specific forecasts. Then basically, it will apply those forecasts, as I mentioned, to a historical year that a historical hydrograph. And then from there, we can actually manipulate that hydrograph that we want in many different ways, whether it's shifting the hydrograph, we can ratio different parts of it, whether it's more of the monsoon season, we want to show a more bigger monsoon season, lower monsoon season. There's a whole bunch of ways that we can manipulate these hydrographs that go into our model. And then another thing to mention is the inflows and outflows of the different reservoirs. They're based off of basically both nature and policies. So the inflows essentially from the NRCS, you can kind of think of those as those are basically the what nature is providing, and then the outflows from the reservoirs or even inflows from reservoirs that are downstream of other reservoirs are based off of different policies and that are in place. One other thing to mention, I also previously mentioned before, is Article 7 restrictions. That's not going to play as big of a role this year with the construction at El Vado. But it is something to keep in mind in terms of not being able to store in those reservoirs that are post 1928. Something else that the model takes into account is flood control and channel capacities downstream, which those will definitely play a part, particularly the channel capacities in this year's model runs. And then there's also, the model also takes into account different timing of water deliveries for different contractors and everything, and water users. And it also looks at demand of like the irrigation districts and what they need. And it takes all that into account when creating these projections that you'll see. So just to kind of give you a graphic on how it, on kind of the beginning part of what I mentioned, of what I was talking about before, where we take the NRCS forecast and develop these hydrographs. So starting from the left, you can kind of see a little graph with a box that says March to July. In there, we'll get the NRCS/NWS volume. So we'll use that volume, and the model will default to using the closest historical year as the hydrograph, and it will apply that volume as that hydrograph and ratio it up and down based off of the NRCS forecast. So basically, just think of it that it for all these headwater gauges that we get this forecast for, it will basically use the whatever year that the model shows as the closest, and it will basically map that year on there, and then it will ratio that up and down to match the NRCS forecast. For our runs, we did decide to kind of use modeler intuition and override what the model thought, or the model said was the closest year. And we chose the year 2010 hydrographs, as we thought that was an appropriate year based off of the runoff timing and the snowmelt volume for that. Just looking at all this, basically the SNOTEL gauges and kind of comparing them to historical years, we believe that 2010 was a pretty good year to choose compared to what the model was kind of hinting toward choosing, I guess you could say, because originally it was choosing stuff in like the 1980s. So, but just to kind of go through them just very quickly again. So the very first three are off the Rio Chama. Well, I should say Heron. Well, so let me rephrase that. Heron is directly off the Rio Chama, and that's a reclamation facility. It stores specific or just San Juan Chama water supply and is also utilized for recreation. El Vado is the first reservoir that's actually on the Rio Chama, and that's also a reclamation facility. It can have both Rio Grande and San Juan Chama water supply. The Abiquiu is a core facility. It also is utilized for water supply, recreation, flood control, and sediment control. Cochiti is then the first reservoir that's on the main stem of the Rio Grande, right below the confluence of the Rio Chama and the Rio Grande. And that's a core facility, and that stores basically, it basically is used for San Juan Chama water supply, recreation, flood control, and sediment control. Another reservoir which has already shown to have some pretty high flows this year that we'll mention is Jemez, and that's also a core facility, and that's strictly used for mostly flood control and sediment control. Going downstream further on the Rio Grande is Elephant Butte, which is a reclamation facility that has both Rio Grande and San Juan Chama water. Can be used for recreation, flood control, and flood control purposes. And then finally, there's Caballo, which is a reclamation facility, and has Rio Grande water supply and is used for recreation, flood control, and sediment control. So first, I just wanted to kind of go back and look at 2022, look at how our model did last year compared to what actually happened. So for this, I'm just basically going to look at all those reservoirs that I previously showed. For this, the inflow will always be in the top left, the outflow will always be in the top right, and the storage will be always on the bottom. And then the dotted line will be the actual inflow, and then the modeled inflow will be the solid line. So looking at 2022 Heron inflow, you can see that we actually in our model run, we actually kind of overestimated the snowmelt season. We expected it to go more into June, and it basically what that snow that was up there just did not accumulate, and the inflow into Heron basically went pretty much straight down right after the peak in mid-May, late May, and from there we just have a few little spikes based from the monsoon season, and then you can see a few spikes in which was our model monsoon season as well. In terms of Heron outflow, we did fairly well on this. You can see the peaks are basically us releasing doing rafting releases from Heron. Because of the construction at El Vado, we had to do rafting releases out of Heron instead of El Vado. So yeah, all these different peaks are basically just us doing these rafting releases. And then the one thing that we did model that was pushed back a little bit later was Albuquerque releasing some of their water. Or the model had Albuquerque doing this blocker release in August, and that didn't actually happen until you can kind of see going up until September. The model storage ended up being higher because of extra snow that we were expecting that just didn't accumulate. So it ended up peaking up at 90,000. What we actually got was closer to 85,000. And then from there, they kind of switched, which is in August, which is basically that difference between when Albuquerque decided to release its water. But in the end, they both ended up around 40,000 acre feet. And that was kind of, that was a little bit attributed to the good monsoon that we had last year in terms of just some extra little inflows that happened throughout the year. Going downstream to Elvado. So for Elvado inflow, again, you can see that we overpredicted in terms of the modeled inflow compared to what actually happened. We were expecting a peak maybe closer to 3,000. That only about 2,000 CFS actually accumulated in terms of Elvado inflow. After the snow melt, though, we did fairly well. I mean, the ups and downs might not match exactly, but it was still around what we were expecting, and it trailed off at the very end of October through the rest of the year, around that 75 or so, 100 CFS. In terms of Elvado outflow, actually, I'll go down to storage because this is that pretty much tells the whole story here. Is basically for 2022, as folks may know, we had to pretty much drain Elvado due to basically construction on the dam. In terms of the modeled storage, we did predict that we were going to drain that a little bit sooner than we actually did. But by June 1st, basically the Elvado was sticking around that 2,000 acre feet, and that kind of remained for the rest of the year. And then in terms of just kind of going back up to the outflow, you can see that over prediction again for the snow melt, and then everything was pretty much in inflow equals outflow past June. Going down to Abiquiu, same story. You can see that slight over prediction from modeled inflow, and then basically everything else kind of matches up fairly well. So I'm happy with that. In terms of 2022 Abiquiu storage, both the modeled and the actual managed to line up fairly well as well, despite that over prediction from the snow melt, which you can kind of see in the beginning, but then some of the monsoon inflow kind of catches up, and actually then the actual storage ends up being higher than the modeled storage toward the very end, but still very close. In terms of Abiquiu outflow, there was about 5 days or so of flood ops from Abiquiu, where it got up to the 1,800 CFS, and before it came down, the model it showed about a week or two, so a little bit more, but otherwise it still showed it coming right down and kind of staying between. And then the releases for post June 1st match up fairly well. There's a few spikes here and there of when people may have called for water or a monsoon storm that didn't match up exactly, but it in general matched up fairly well. For 2022 Cochiti inflow, again, you can see for the snowmelt period, basically April through June, even a little bit into July, the model was again a little over predictive. But then you can see post July, this is where you can really see the effects of that monsoon activity that was going on throughout the year. Particularly, and this is happening above Cochiti, so particularly August, September, even into October, you can see spikes basically from those big monsoon storms that were occurring throughout the state. Cochiti is generally inflow-outflow reservoir, so you'll notice that Cochiti inflow and outflow pretty much look exactly the same. And then in terms of Cochise storage, that stays about the same all year round as well. Just it mainly has water for the recreational pool, and anything that's stored in there is just making up for evaporation losses. And then finally going downstream, I shouldn't say finally because there's still Caballo, but going downstream further to Elephant Butte, here is where you really see the impact of all those monsoon storms. And it was quite an amazing season in terms of that respect. So looking at the modeled inflow, again, you can see over prediction the snow melt, and then after June, huge spikes, basically some spikes reaching above what the actual snow, if you look at just the actual inflow, you can see spikes post-June from the monsoons that are even greater than what came from the snow melt period. And that basically continued through most of the year. And going down to Elephant Butte storage, that's that's basically the picture that you see here. So you will, so the model storage again, it was higher than what actually happened because of the snow or over prediction of the snow melt. But you can see that they quickly switch places basically around mid-August or so, where those monsoons really pick up, and we ended up ending the year at Elephant Butte a lot higher than we were originally expecting. And then in terms of the Elephant Butte outflow, we started pretty much right when we expected to start. The main thing is that releases at Elephant Butte ended about a month earlier, not quite a month, than we were originally anticipating, and that was a lot to do with the monsoon storms as well, with the districts down south getting a lot of extra water on their land and not really calling for as much water from Caballo as we originally anticipated. Then going downstream to Caballo, again, one thing to mention, Caballo inflow is pretty much Elephant Butte outflow. So you can see that we did good for the startup day, and what actually happened is they ended up, and you can see in the Caballo outflow as well, as they ended earlier than we expected, and also the demand, which is essentially the Caballo outflow, was lower than we were anticipating, again, because of those monsoon storms as well. And then one thing that happens twice that you can really notice is the big peaks in the Caballo inflow that happen late August and early October. And it was funny because it was basically right when we shut off Elephant Butte that we got a fairly nice storm that happened that brought flow right between Elephant Butte and Caballo, and shot up Caballo up to about that 35,000 acre feet. And about 2 months later, same thing happened again. A really good monsoon storm hit right between Elephant Butte and Caballo, and it shot up to about 50,000 acre feet, which is where we are starting this year. So Andrew kind of went through all of this, but I will just go very quickly through this part. So as mentioned, there's a bunch of snow-tell sites all throughout the mountains. Up in the upper Rio Grande, up here is where a lot of, I'll be showing a couple snow-tell sites from up here. I'll be showing a couple snow-tell sites from the Rio Chama, and then I will be showing a couple of snow-tell sites from the Sangre de Cristo Mountains, and these are basically where we get most of the flow from that snow melt that we'll see downstream. So just quickly starting Rio Chama snow data. This is a low elevation site, Chamita. And these are all going to be, paint the same picture that Andrew has already mentioned. And the picture is very good SWE and very good precipitation that occurred above average in both cases, sometimes close to double the amount of SWE like you can see at this site. Right now, you can see that it's the SWE snow water equivalent is headed down, and I should back up here for a second. So in these graphs, this blue line is the current year SWE 2023. This black line right here is the precipitation accumulation for this year. The gray line is the median precipitation accumulation, and then the red line is the median SWE from the the median is from the 1991 to 2020 period. But you can see, just like you saw in Andrew's presentation, we're in really great shape. And as mentioned, even if we did lose some of this to sublimation or evaporation, there is a lot up there. So it seems like it's going to be a really good snow melt runoff. Going upstream to a high elevation, still on the Rio Chama, this is looking at the Cumbre Trestle snowtail gauge. Again, well above average in both SWE and precipitation. Not much more to say. Going over to the Rio Grande, so this is more in the upper Rio Grande. This is an upper Rio Grande site, low elevation. You can see the SWE again, almost double the median. Just starting to come down right now, about when it seems to be matching similar to when the median SWE is making its final kind of drawdown as well, although it does look like the median draws down a little bit earlier here. But in general, yeah, still really good shape. This is the high elevation gauge in the upper Rio Grande. This is the Wolf Creek Summit gauge. This hasn't even began. You can see that it hasn't even started the snow melt run to actually melt off, I should say. It's still kind of climbing up there. I know that this and actually I think most of the gauges that I've mentioned and will mention have already gotten another little bump from this last weekend kind of little storm that occurred. So hopefully that those little storms will continue to happen. And I mean, we're already in a good spot, but we could always use more. Going over to the Sangre de Cristos, this is low elevation elk cabin right near Santa Fe, essentially near the mountains up there. The site has actually already melted out, as you will notice. But before it melted out, it was still almost double what, I mean, the site usually doesn't get too much in terms of SWE, but I mean, still it's about, double what the median was. So yeah, I mean, I don't see it being bad in terms of snow melt runoff at all in any aspect. Going up to a high elevation, Taos Powderhorn. Again, this one's a little bit less than maybe the other ones compared to the median, but still above average, and pretty much how most of the sites are up there. So now to kind of get to probably why most people are here is the 2023 projected water operations. So here I will basically kind of go through what Reclamation and the Corps and ISC kind of collaborated with creating these model runs. So I just kind of wanted to go through some assumptions when using when you actually see these model runs. So as I mentioned before, we use the 2010 hydrograph shape, at least at the headwater gauges and tributaries that we used and then again that NRCS forecasts applied to that 2010 hydrograph shape. We also have we're still doing construction for the El Vado Reservoir, so we still have the restriction of the 6,785 feet plus or minus 1.5 feet, which essentially is around 2,000 acre feet. And that restriction is throughout the year, except during the runoff time of April 1st through May 15th, which we can theoretically go up to about 6,800 6,800 feet, which is equivalent to about 9,400 acre feet. And that's just to kind of give us some leeway, and we'll definitely need it this year with the great snowpack that we have up there. And then the other thing to keep in mind is that because we're restricted to such a low elevation, the likely expected maximum release that we can actually get out of El Vado is about 3,500 CFS. So that's lower than what is usually the max release out of El Vado, just because of that low head from the low elevation. Yes.
So if the inflows are double that, you're still restricted.
Well, it's not, I wouldn't say restricted, but I mean, it's however much that the reservoir can actually put out. So, I mean, it's physically impossible.
Oh, okay. That's
Steve, it's a physical limitation.
Yeah.
Because there's no head.
Yep. Going downstream to Abiquiu, so P&P water, again, or because we're doing the construction at El Vado, we're having another year where we're going to be storing the P&P water in Abiquiu, and that will be about 14,500, at least in these runs, and that's actually already retained. It's already in the reservoir, or being stored in the reservoir, and it will be released, and we'll release any unused water, any unused P&P water by the end of the year. And then there's also going to be maintenance on Abiquiu, which Ray will talk about a little bit more later. And that's likely going to restrict releases between 50 to 75 CFS starting on November 15th.
It may change to up to 50 CFS. So
Oh.
Well, we'll talk about that later.
There you go. Then for MRGCD, we already have a staggered start date, and actually, as of now, I mean, they're in pretty much full operations as well. And then going down to Caballo operations, we're expecting a start date for Caballo releases to start around May 1st, and that will just be releases to the Hatch Valley, and then May 12th is when basically everyone will come online, EBID, EP1, and Mexico. And we're thinking that the total release out of Caballo for the project will be between 450 to 600,000 acre feet, with most likely around 530,000 acre feet. So I did want to kind of, before I actually showed the forecasts, one thing that we are doing a little bit different this year than we usually do, well, in previous years, we would always just show kind of one line and say, this is what we think it will probably be. We're going to try something a little bit different this year and kind of give you a range of possibilities. So all the graphs that you'll see coming up will look very similar to this. So the black line will be observed data, which will be from January to about April 7th or so. The purple line will be the most likely scenario, which is equivalent to the NRCS's 50% exceedance run. So basically that means that 50%, there's a 50% chance it could be over that purple line. There's a 50% chance it could be below that purple line. Next, you'll see a blue shading, which is shading between 30% and the 70% NRCS exceedance run. So for example, the lower point on that blue shading would be equivalent to the 70% exceedance run, and that means that there's a 70% chance it would be over that lower point on the blue band, and a 30% chance that would be lower than that point on the blue band. And then finally, the green shading is is looking at the 10% and the 90% of the NRCS exceedance. And of course, because it's the 10% and 90%, there's still the chance that it could still be outside those bands. But we still want to kind of give folks more of an idea of what it could be instead of just providing kind of one line. And then just to quickly go through the NRCS forecast and kind of comparing it this year to last year. And this is just looking at the 50% exceedance, which is that most likely scenario, as I mentioned. You can see everything is up across the board, essentially. Rio Grande at Del Norte is at 130% of median compared to 78% of median, which it was last year. Then you can see that for the Rio Blanco diversion, so that's what we get from the San Juan Chama project off of that diversion. That's at 156% compared to 83% last year. The Navajo diversion, almost double what they were expecting, or we're getting almost double what they were expecting last year. El Vado inflow, we are getting above double, or well, I shouldn't say we are, but they're expecting we will get above double than we're getting next year. And that's just the case throughout all of these. We're just the NRCS is expecting a really amazing year. So, and
what's the point of comparison to 2022 actuals? Roughly the same?
The actuals for 2022. So, the different these are it was closer to the 70% exceedance last year. Which I guess is something to mention when I was showing the observation graphs previously. The line that we showed last year was the 50% line, which is why we overestimated in those results. And this is, like I said, this 2022 is just showing the 50% as well, but actually it was closer to the 70%. So what actually happened was even lower than these, and I'm assuming most, if not all, of those sites.
So your El Vado inflow is just native Chama water, or is it space?
It's just native water. Yeah. And then the last thing, just to mention, just to kind of hit home that it's going to be a likely amazing runoff year. So this graph shows the native flow at Otoe. It was for the time when it has the San Juan Chama project on. We kind of corrected for that in this graph. It's to only show native flow. And you can see that the red lines are the different forecasts for Otoe, the 90%, which is the lowest, then the 50%, which is in the middle, and then, the 10%, which is the highest red line there. And you can see that all three of them are above the 30-year median. So, and then even looking at if we do manage to get the 10%, which would be extremely nice. I mean, we haven't had, you can see that 10% line hasn't happened since about 1994. And this is basically just what the NRCS forecast is kind of showing. And for the 50% forecast at Otoe, it's showing kind of similar volume as 2017. All right, so to finally get into the actual projections, starting at Heron Dam off of the Rio Chama. This is kind of similar to how I showed these graphs before. The inflow will be in the top right, inflow top left, outflow top right, and then the storage will always be on the bottom. Sometimes there'll be another graph as well if there's something else that I want to show. So in terms of Heron inflow, you can see that one thing to mention with the Azotea Tunnel, that goes in, that delivers the water from the San Juan Chama project to Heron is the maximum capacity is around 950 CFS. You can see that for Heron inflow, we actually exceed that, which is from everything above that is essentially from Rio Grande water snow melt that's coming in from Willow Creek, which also comes into Heron as well. So it's getting a mixture of both maxing out Azotea Tunnel as well as some water from Willow Creek as well. And I didn't put up a plot of Azotea Tunnel, but if I did, it was basically maxing out Azotea Tunnel for a good portion of April through early June. Going over to Heron outflow, we're projecting that we're going to do very similar to last year with kind of all those ups and downs are essentially the rafting releases. You can see a few kind of chunks of water here and there throughout this, and that's the other contractors such as MRGCD and Reclamation and Albuquerque releasing their water for downstream. Going down to Heron's storage in the bottom left, you can see that we're expecting to kind of max or get a maximum Heron storage around mid-June of around 130,000 acre feet, and then ending the year at 90,000 acre feet approximately. And that's actually going to result in all runs, essentially the San Juan Chama allocation being a full allocation for the year by July is what we're kind of projecting, which would be the first full allocation since 2019. So that will be nice, especially for the last 3 years that the allocation has kept on creeping down in terms of how much gets allocated. So yeah, it looks very likely that we will get a full allocation for the contractors, and with potential of having a good amount left over for next year as well.
It's going from 10% to 25%. We're starting at 40,000 in Heron, which is the 400,000.
Oh, I see what you're saying.
Doubling.
Yes.
10% to about 25%.
Yeah.
So the projection, I can't see the index numbers, end of the year.
90,000 acre feet. Yes. Going downstream to El Vado. So as mentioned a couple of times, again, we're still doing construction at El Vado, so those restrictions are still going to be in place. During this time, we'll be restricted to 6785 feet plus or minus 1.5 feet, which, as I mentioned, is about 2,000 acre feet. For the runoff period, we can go up to about 6,800 feet, and that's approximately 9,400 acre feet. And that's just to kind of give us some relief because especially this year with inflows being so high and us not sure how much we can actually, in terms of the maximum release out of El Vado, we believe that's going to be around that 3,500 CFS.
So what elevation are you at now? Have you been storing up to that 6,800?
No, we are currently around 2,400 acre feet, so we're still kind of around where we were.
7 elevation, something like that.
Yeah. So
And
We're,
construction doesn't feed you for maintaining 9,045 400 spot.
well, they're
I
going to.
believe it's more that there is an awareness that we may not be able to release water as it comes in, so they are not allowing construction down in an area that might be dangerous for the contractor, so they're allowing us a little bit of leeway.
Okay, so you would store throughout the season.
No,
No.
it's only for runoff, so it's only to allow safe runoff and keep the contractor out of that area for during runoff. Then when we tell them, you know, when we get down to something stable and we feel like runoff's over, then we'll tell them and they'll begin working lower down in the reservoir.
And then, as with last year, rafting releases will be managed from Heron and bypass through El Vado. So going through the projections, again, El Vado inflow, which is the top left. As I mentioned, this year was we used the 2010 hydrograph, and in 2010 it actually produced 2 peaks. Whether we do get 2 peaks or 1 big peak, I know we already kind of had a little slowdown right now, but it's head back up. So we'll see what actually happens in terms of that shape of that hydrograph. But we're expecting a peak of around maybe 3,500 CFS to come in into El Vado before and kind of to be sustained. I should say. And have about 2,000 CFS being sustained through pretty much mid-April through almost June.
The double peak is an artifact of 2010, not because of construction.
That's correct. And then from mid-June to basically September, so we're showing those peaks from the rafting releases and also any contractor water that's being released from there. In terms of El Vado outflow, you can see that again, because of the construction, inflow from El Vado is pretty much going to equal outflow from El Vado. The only difference between the inflow and outflow is that cutoff at 3,500 CFS, which is what we're predicting as the maximum release at that head. And then going down to storage, we're expecting just to stick to around that 2,000 acre feet for the entire year, except for any runoff that we will have to that we can't store due to basically because of the high runoff. Going downstream to Abiquiu Dam, I'll let Ray take over.
Good afternoon. My name is Ray Del Grito. This is Abiquiu, and as Lucas described, there are probability bands, but we're going to focus on the most probable, the purple. Abiquiu inflow began the year pretty low, and outflow is we matched outflow to begin with, and as spring runoff, the inflow has already actually begun, and we're near about 1,500 CFS currently. On the model here, it's showing about 700-800, but we're already at 1,500. And so we're expecting about 3,500 CFS during runoff inflow, between 3,000 to 3,500 CFS, and as runoff is nearing complete, you see that we'll start to average out about 500 CFS. Some of those spikes in there are for we're receiving rafting releases, and typically you'd see the outflow reflected in we typically just store it during this period, and anyway, we're receiving rafting releases out of Heron this year, and we'll start to drop off toward the end of the year to about 100 CFS. So the outflow this year, we're expecting about 2.5 months, or maybe up to 2 months of max releases of 1,800 CFS, and there is a potential that we might have to have a flood storage locked in till the end of the year, where we'd have to release it. And our outflows could have probably after the runoff period, our outflow is gonna average about 400 to 500 CFS till the end of the year. And then, we have a little block release there where we're gonna release, if any PMP still in storage, we're gonna release that. And any other water that needs to be, released before the end of the year. On November 15th is when we're gonna start a construction maintenance period for, at Abiquiu. And we're restricting releases to up to 50 CFS. And that's what you're gonna see at the end of the year. And the reason for that is that, personnel safety, we're gonna have a diving team out there, and we were given a range of, up to 140, feet in depth, water depth. So we're trying to match that, and folks are gonna be down in the construction area, which requires us to keep our releases down to 50 CFS.
These relationships.
Well, we have to keep they're gonna be in the conduit, doing a bunch of maintenance and repairs. And so we have to keep that release down to 50 CFS, so that's for their safety. They're gonna put up, cofferdams to allow for water to continue. But
minimum release during this construction period, which is starting November 15 and in February the following year, that would be closer to 50 CFS.
yeah,
But the depths
Minimum.
is not gonna be
Maximum.
maximum.
the max release. The release will not be higher than.
This max number keeps coming down. It feels like every week.
It was originally 30 to 50 that
It was closer to 75, and yesterday I just got the information that from the team that working that site, it's not gonna be more.
And we talked through that is more than enough to, San Channel water could be part of that.
Yes, San Juan Shama releases will be part of this.
You're not going any lower, right? Not gonna give us a lower number next week.
No, it's not gonna be, no, it's not gonna be lower than 50, because we had this discussion yesterday with.
Because like 3 weeks ago from Ryan, it was 115.
No.
Well, that's what he said. And then it was 70.
When did, no, we never mentioned 115,
So that's
and
called,
it should come from,
50. 50
yeah,
is-
from water management.
can I ask a question, Ray, about the flood storage? So you mentioned that you might be locked in. So my understanding is after July 1st,
Yes,
you can, that's locked in.
After July 1st.
after July 1st, if the Ottawa natural flow goes below 1,500 CFS. So if we still have natural flow coming from Colorado after July 1st, more than 1,500 CFS, we continue releasing this flood water.
Okay, so that's I think you just hit on my question. So the period of time that we will not be able to release San Juan Chama water
We
would,
can extend a little bit if actually we have the Ottawa gauge has more than 15.
and then if it dips below 1,500,
1,500, we have to keep this water in MQ and start only bypassing the inflow and start releasing San Juan Channel.
and then that water that is held back in that scenario, it has to move eventually by the end of the year.
It has to move, but the only window that we have it to move it, it's between November 1st and November 15th. So we may go back to 1,800
That's good.
during that period, and at that time also, we will not be able to release San Juan Channel.
That's where I wanted to walk to. So when do you think be the earliest time that you know we're in that situation?
During June,
Okay.
we will know. By early June or late May, we will know exactly how much flood water is expected to be.
Okay, and then how long you think it would take to move in that? So that I want to be able to anticipate being able to
We,
run.
we will give you a head,
Okay.
advance notice about what's gonna happen. And we're also talking with the Rio Grande, gonna be talking with the Rio Grande Compact Commission to maybe continue releasing this water, even if the Ottawa goes below 1,500, but that's depends on the agreeing this, because we need to get this water.
Yeah.
as soon as possible.
And I don't want to be moving my water to Elephant View in July. or
Yes, I agree with you.
So if we can help with
You
that.
will have lots of loss.
Yeah.
Part of it has to do with how San Luis is operated, right? Part of this is driven by how the San Luis, up in Colorado.
It's coming down.
No, part of this is just because of the think that if they release this water during, after July, it's gonna be used in, middle of the Grande.
And your objective is to get all of the flood water out according to your man.
And not
That would-
diverted by.
Any numbers you'd have to release after November 1,
After,
but before the.
Will you know Friday if you're able to work with the Compact Commission or?
we're talking to them right now.
Does they have a meeting?
Yes,
Yeah.
we're gonna do the request usually on Friday,
Okay.
and then we'll see what's gonna.
Now we move on to Abacu storage. We started the year with 100,000 acre feet, and with the runoff inflow, we're looking to maybe peak about 200,000 acre feet, and that's just about 6223 maybe. It's actually pretty good. I don't think I've been here 6 years now. I haven't seen it that high. And we're gonna finish out the year probably about 100 and maybe 135, 140 acre feet. This is the Embudo gauge. We started out the year about 500 CFS averaging, and with the runoff starting, we're gonna probably peak, or we're probably gonna average through the runoff period about 2,500 CFS and peaking about 3,500 CFS in June, and then drop off back down to about 500 CFS for the remainder of the year. Next is Cochiti Dam. Cochiti Dam does not store any native water, so all inflow will equal outflow. We've already started to release about 3,500 CFS or 3,300 CFS currently. And we're gonna probably be averaging about 4,500 CFS through the runoff period and peaking maybe about 5,000 CFS at some point during the runoff period. Everything else after the runoff is completed, we're probably gonna be averaging about 800 CFS out through the rest of the year. The storage is pretty much going to be sent to our rec pool of 1,200 surface acre, which is about 43,500 or 43,500 acre feet or something like that. This is the MRGC demand, which is the red line, and as you can see, all our releases are going to satisfy the MRGCD demand throughout the irrigation period. Jemez Canyon Dam is a dry dam. All inflow is going to equal outflow. We don't expect any storage, even though you see that we might peak about 1,300 CFS according to the model, but last week we peaked about 1,500 CFS, so we might have already passed the peak. So. Trying to get back over to Lucas.
So looking downstream of Jemez, going to Central, which is basically right down, actually that way, right outside. So you actually notice right now we're already at around 3,000 CFS at pretty much, what was I gonna say, better than what we've seen for the last 3 years. So we'll see if we will end up actually beating out 2019 as well. For this year though, for the rest, for the actual runoff period, we're looking at around 4,000 CFS running through Albuquerque from maybe mid-April to mid-June. Before coming down in late June to around 500 CFS, and then kind of getting lower toward the fall, and then coming up again after irrigation is over in October, November, December time period. Downstream a little bit further, looking at Santa Casia. So we're expecting pretty much the same as Central, just kind of reduced a little bit more. So here you'll see from mid-April to mid-June around over 3,000 CFS for a good, most likely for that period, before falling down around late June with the end of the runoff period. And then, as always, we'll probably have some drying starting maybe in July. Down there.
These late months, this is all taking into account the AVAQ work.
Yes. And then one other thing to mention that I probably should have mentioned in the previous slide, when doing these model runs, we did look at dampening down the monsoon season. So you'll notice, just to be conservative, there's not really many peaks in here. So hopefully Andrew thinks that it will end up being better than that. I mean, I'm hopeful. So yeah, that could be. This could be much higher during this period if we do get better monsoons. But for the purpose of these runs, yeah, we're trying to be conservative in terms of the monsoon season. So for the Rio Grande project operations, we're expecting 55% to 75% of normal releases from Caballo, which is going to be over 4 to 5 months. This is going to be fairly similar to what it was in terms of releases for 2019. And we are estimating a full supply for Mexico. So to start off, just looking at the Rio Grande project usable storage, I believe, I don't know what the official date is or if we have an official date, but I know by now we are out of Article 7. And I'm just going off of the most likely. You can see that we'll probably be out of Article 7 all through possibly the summer up until September, and then maybe go into Article 7 briefly. And then if we're lucky, the likely scenario shows that we'll actually go out of Article 7 again at the end of the year.
Friction is done, right, Jen?
No, but I was gonna provide some good news there that New Mexico and Texas resolved their difference over the credit water, so there is only one Article 7 instead of 2.
How'd they do that? Rochambeau or something?
Texas this is public,
Not the negotiations aren't public, but the
the
answer,
resolution.
the resolution is.
Texas was feeling generous and gave New Mexico some credit water.
Do you have any data to show us on that?
No, not in these slides, nothing for the credit debit.
So we could, if we had it, we could talk about last year, but predicting it is pretty.
But if this were within the blue lines, can I infer that we're not gonna whittle debit?
No, you can't infer that from the storage because it's looking at how much passed
Somewhere
Ottawa
else.
versus how much gets to Elephant View. So even if it's a great year, we could still be in debit for New Mexico.
Well, I'm certain.
Well, it can still be in a lot of debt.
This one,
It really depends on if the monsoons show up.
there's going to be a debit tracker and stuff.
I'm wondering about
For
that.
us.
I will advocate for that because we went up to work on an emergency basis on the MS flows, and it was on Pueblo, so it was an easy decision for us to make to mobilize up there. But part of that thinking about how important that water was, is it doesn't bring the gauge, so it's kind of free, compact water. So we are expecting to get paid back from the state for that. But, yeah.
You went from ISC on the.
Yeah, they're on the call. But it's also an emergency. They're declaring an emergency, so there'll be an emergency funding.
Are you taking a betting pool for end of year? Article 7?
That will make the tracker happen.
Yeah, right.
There's lunches at stake.
Burgers and beers.
But we do know what the debit line is currently.
Yeah, we know day to day. That's what I was wondering is, do we know day to day?
Our model track, our accounting model tracks. the database.
Yeah.
And did these gauged tributaries flows make a difference in reducing the dip?
I would have to double check what's
Yeah.
coming in. I mean, I'm sure it did.
The 30,000-ish credit from, that moved from Texas to New Mexico in the agreement, plus the monsoon rains from last year improved New Mexico's situation with the contract.
I think it's under 100,000. I
Yeah.
the page is on. I can jump in, but yeah, it's under 100,000.
And if I want the real number, I'll go to compact.
Yes, it won't be official until Friday.
Oh,
I'll be on
last year,
there.
last year's number, right?
And by the way, Lucas, keep that 1,400.
All right. All right, so to look at Elephant Butte Dam. So here for Elephant Butte inflow, expecting the runoff period from April or mid-April to mid-June to be around 3,000, actually over 3,000 CFS before dropping down in late June, early July, similar to all the other hydrographs that I shared, with very little coming in over the late summer, early fall period, and then kind of coming back up in November. In terms of Elephant Butte outflow, as I mentioned in the previous slide, we're expecting Caballo to come on May 1st, and we're expecting that will also come on at Elephant Butte on May 1st as well. And then that releases from Caballo and Elephant Butte, could last up in through October, depending on how good the year actually turns out. In terms of Elephant Butte storage, we're expecting a peak in late June to be almost up to 600,000 acre feet. And that's pretty much equivalent to 5,350 feet in elevation. 4,000, sorry, 350 feet in elevation. And then dropping down through irrigation season down to about 300,000 or so acre feet. And then coming back up to maybe 400,000 acre feet at the end of the year, depending on demand at Caballo. Going downstream to Caballo Dam, Caballo inflow, very similar to Elephant Butte outflow with some little intervening flows that's modeled. So they're pretty much equivalent to each other. And both Caballo inflow and Caballo outflow kind of share the same picture in terms of coming on around that May 1st start date. Then there will be, from May 1st to May 12th, there'll be a little outflow from Caballo, maybe 200-ish CFS for the Hatch Valley before all the districts, before the two districts in Mexico come on May 12th. And then you can see the demand shoot up to maybe 2,500 CFS, and then kind of getting lower throughout the year. We're expecting maybe EBID to shut off around late August. And then EP1 in Mexico to kind of shut off somewhere around maybe October. And then in terms of Caballo storage, you'll see that we're kind of, will initially, when all the districts come on, we initially drop down a little bit to maybe 3,500 acre feet, or 35,000 acre feet, sorry. and that's basically due to Caballo outflow being more than we can release from Elephant Butte generators. The generators we can only get so much outflow just from Elephant Butte generators. And then as the Caballo demand kind of wanes off, we basically stick around that 3,500, maybe or 35,000, 40,000 acre feet before ending the irrigation season or in October around 15,000 acre feet, which is what we've been doing for the last couple of years. And I think, yep. That is actually it for in terms of the projections. I did want to very briefly mention that Reclamation has what we call a water ops dashboard that we created. The link is in the top right, and I think Carolyn also put the link in there. I don't see last, so she was supposed to put the link in the chat, but we can send it out to anybody that has any questions. This will essentially kind of give the last 7 days worth of data at most of the USGS gauges, some of the reservoirs and everything for both the Rio Grande, Pecos, and there's also a few other tabs just to kind of get a better look at maybe reservoir conditions and MRTCD conditions. It's still kind of, and then another thing to note is that, so the top right link actually links to our AO operations website. In there, you'll notice if you go to the right column, there'll be this operational data kind of column in there. There's a little bad star that I drew with an arrow that shows where the water operations dashboard link is there. And then also the arrow above is a link to our monthly projections for the Rio Grande project that we put out every month.
What are the negative numbers? Just one down.
Oh, you mean this negative number?
Yeah.
So in this, just to kind of go through this very quickly. So this is basically change. So this is the change from the previous day. So this will take whatever time. So this is the current, the latest data is whatever time that this came in from. So like for this site, it was April 13th at 7:30, and it will take this this value, which is what I can't even see that, 199 or something like that, subtracted from exactly 1 day previous to that number, and then that will be that change.
Another thing to keep in mind is that standard time.
Yes.
Not daylight.
Yes.
Yeah, they are.
Model doesn't know about light savings.
Well, once it goes away, we won't have to worry about it.
This dashboard's great, like I said.
Yeah.
I use it too.
Really good feedback from lots of people who know about it now.
How long is it?
Thank you.
I think we got it up in like February-ish time. Yeah. So only a few months now. It looked like this.
Thank you very much, Luke and Ray. I know we asked questions throughout, but if you want to type any questions, I think
That picture of.
that's the bottom.
Operation.
That's the bottom of Reclamation's Rio Grande project. That is in Hudson County. That's where our tailwater gets stored.
It's evaporating.
They use it to water trees, plant trees.
I guess maybe one big question is, are there any out year maintenance projects like the Abiquiu conduit that you haven't told any of us about yet? So they don't come as more surprise.
There are some things on a list, but nothing that somebody's come forward to us and said, these are the things that we want to do in 24, 25. So one of the ones is vent shaft replacement at Abiquiu It's part of the Los Alamos County powerhouse relief, that draft release or whatever it is. I really don't know how it works, but I've seen where it is. It's like a probably about a 90-foot section that they want to replace on both shafts.
Would that affect reservoir levels or bypass?
So I guess they replaced the collar before, and during that period, they said that they were able to release up to 150 CFS. Otherwise, if they go up too high, there's a draft that pulls the air in and could cause some, air quality issues for the folks working in the bell chamber. So
That's a post.
yeah, that's yeah, like I said, it's on a list, and that's probably the only one I've seen that would really make or cause an issue in terms of releasing, or I don't want to say an issue, but limit some sort of release. But that's, like I said, they were saying 150 CFS. If we're releasing less than that, then it's not really an issue.
Did you see it? Good news about Elvado construction?
We have gotten some news on Novato. It's not shareable today. It's preliminary from the project management team. I will share it at the Compact Commission. I guess that's 2 days. It's almost shareable. Sorry about that.
Are you working on the spillway this year too?
Yeah, I was debating about whether to bring that up. I think folks know that the spillway project, Alvado's got 2 projects built into it. There's reworking the faceplate and the embankment work. That was phase 1. Phase 2 is the spillway. They will we don't want both contractors out there at the same time. It's a small work area, so there will be sequential. Replacing the faceplate will bring the allowable storage back up to where it was before we had all these concerns, but not fully because of the spillway. Once the spillway is complete, then the full capacity will.
Is the road, that part of the first project of the spillway project?
Just getting the road
Back.
up and running. Yeah, it's a little bit of a negotiation at the state. It's actually a state highway, so we're returning it to a reclamation dam conditions. If they want it deep and nice, they'll come back and do that.
Okay, we have a question from online for Lucas. Are we expecting Isleta Reach to have similar peaks and flows to Central and San Acacia?
Yeah, I mean, well, so, I mean, it won't be exactly the same as Central, but I mean, it degrades as it goes downstream generally, so it will be less than Central. But I mean, it will be a similar shape.
Okay. Well, I really appreciate everyone for attending. If there's any more questions, I think we'll do them offline. I did put in the chat that if you did not receive an invitation to this directly from Reclamation and you would like to next year, to provide me your email, or send it to Carolyn Donnelly at cdonnelly@usbr.gov, and you will receive the invitation directly from us next year. And that is it. We are going to post the Reclamation and the Corps presentation on our website, so that will be there soon. Or if you just can't wait, you can email Carolyn as well and request it. And when I end the live event, it'll just kind of disappear for you all. But there was a maximum of 46 attendees online. So we really appreciate all of you for being interested in what's happening on the river this year. So thank you for attending, and we hope this was helpful for you all. And I'm ending it.
Thank you.